Good morning. Welcoming everyone to webinar on Wind Turbine Tech 2020, highly efficient, reliable turbine design and engineering services. Today, this virtual event will help us in staying competitive in advanced wind turbine tower concepts for new challenges, emerging markets, and diverse locations. We will have discussions on how today's wind turbines will increase the performance and reliability with next generation wind technologies while lowering the cost of wind energy. An overview of how modern wind turbines are increasingly cost effective and more reliable. I would like to thank our sponsors, presenting partner Lab Razor and platinum partner Shell Lubricant Solutions. I would be quickly launching two polls before we go ahead with our first presentation. Do you think India will be able to achieve its wind target of 60 gigawatts by 2022? I'm closing the poll now. So 38% of attendees quite likely agree with it. Thank you all the attendees. We will proceed ahead with the next poll. Will India develop itself as a wind export hub for Southeast Asian markets? I'm closing the poll now. 59% of attendees agree with it. Thank you very much, all the attendees. With this, we will be proceeding ahead with our first presentation on improved wind blade lap-up process using laser protection by Mr. T.K. Chow, who is the Regional Sales Director, APAC, INDP, Lap Razor. Over to you, sir. Yes, we can view your screen.
Can everybody see my screen? Great.
Yes, sir.
Good morning and afternoon, everyone. Thank you for joining this webinar. My name is TK, Regional Director APAC for LAP. LAP is at the forefront of laser measurement technology and is committed to improving the productivity and quality of wind blade manufacturing, especially with regards to the blade layup process. LAP has seen how global wind trends have affected wind turbine blades both in terms of production demand as well as blade design. Despite the COVID pandemic, global wind power capacity is expected to grow year on year, and according to Wood Mackenzie, global wind power capacity are expected to grow an average of 77 gigawatts per year for the next 10 years. Hence, we know that there's a strong demand for increased wind blade production. We also notice an increased trend towards offshore wind power as it becomes more economically viable, and this has led to the design of larger blades. And as we know, for larger blades, they take a longer time to produce, and more critically, larger blades need to be more robust, stronger, and of a higher quality to withstand offshore conditions. So now the question is, how can blade manufacturers improve their production rate and improve the quality of their blades, especially with the pressure of low tariffs imposed by governments? Now, I would like to invite everyone to dream a little with me. Imagine an entire blade layup process where there will be no need to make physical markings on the mold. No need to make manual or extrapolated measurements. And all operators need to do is to follow laser lines on the mold and lay up various materials from the root of the mold all the way to the tip. And operators can step through the entire layup process and show necessary lines at the click of a button. Well, this dream can be a reality through the value proposition of the LAP laser projection system. I'll play a short video now, and please note that there's no audio track for this video clip. On the mold, the laser lines will show the locations of centerline, glass fiber, balsa wood, other root area materials, shear web, and other things for infusion prep. All these locations will be shown to scale and to millimeter accuracy on the mold. This is how a laser projection system works. The laser projectors will be mounted above each half mold and at a height above the moving factory crane. It is a scalable solution, so if the blade mold is longer, then more projectors can be added to cover the length of the mold. The laser projectors are connected via cables to a control cabinet with a PC and with our software installed on it. CAD data showing the layout material locations on the blade mold is loaded onto this PC, and this CAD data is created by blade manufacturers and are designed using software such as Siemens NX, FiberSim, or Cartier. The CAD data is then projected accurately onto the mold as laser lines or templates. It is also possible to show text as well as the layer names. The laser lines will be drawn to scale and with millimeter accuracy. And then all the operator needs to do is to step through the entire layup process from step 1 all the way to the last production step using the remote control, PC, or tablet. Now let me illustrate to you how all this translates to value for the customer. Now that all alignments can be seen instantly and accurately by following the laser lines on the mold, operators do not need to make markings or manual measurements anymore. This means that your operator workforce can be more efficiently deployed to other tasks, and the entire blade layup time will be significantly reduced, leading to a higher production rate and more blades being produced per week. Because of the high accuracy of the laser lines, there will be less errors, and blades will be produced of a higher quality. This means less cost from material wastage, less chances of possibly scrapping an entire blade, and less chances of costly premature failure. Also, in a high staff turnover environment, training of new staff takes a long time. But if all the staff needs to do is to follow the laser lines, it will significantly hasten the training and onboarding process for new staff. So to summarize, the LAP laser projection system will lead to higher blade production rate, improved quality, lower operating costs, and faster training time, all of which lead to higher profits for the company. Now, LAP has been very successful in the wind blade market, and we have very strong references. The reason for this is because our laser projection system was initially developed for the aerospace composite layup industry that requires a very high degree of accuracy. Our aerospace composite references include Airbus, Boeing, GKN Aerospace, Spirit Aerosystems, UTC Aerospace Systems, and in India, our customers include HAL, NAL, and the Tata Group. So LAP has translated this technology from aerospace composites over to the wind blade layout process. LAP's success in providing laser projection technology for wind blade layout process comes from extensive trials and evaluations carried out by customers comparing LAP with other brands. Some of the trials were done using actual side-by-side comparison over months and using actual production molds. And at the end of these trials and evaluations, it was clear to customers that LAP is the superior brand. Our customers in the wind blade market include Elion in China, LM Wind Power, Siemens Wind Power, and Siemens Gamesa in China, TPI Composites, and Vestas. Some of them are in long-term agreements with LAP. In India, we supply to Vestas India, TPI India, and recently LM Wind Power in Bangalore. To date, we have supplied our laser projection systems for more than 100 blade lines globally. And with such extensive experience and having been selected by customers themselves after rigorous side-by-side testing, it is clear that LAP is a brand and company that you can trust. So who is LAP? LAP is short for laser application, and we are a German company that's a leading supplier of laser projection and laser measurement systems that improves the quality and efficiency of processes. We have 3 business units: healthcare, systems, and products. And our products business unit handles the wind blade market. We design our devices to be easy to integrate and operate, hence our claim of being simply precise. We have more than 35 years of experience in laser measurement. We ship out 15,000 units of devices per year. We employ about 350 staff in 8 locations worldwide. Last year, we had an annual turnover of about 63 million euros, and we are ISO certified. These are our locations globally. We have 3 locations in Europe, including our headquarters in Lüneburg, Germany, that is near Hamburg. We have 3 locations in the US, in Florida, Kentucky, and Texas. We have an office in Shanghai for serving the Chinese market. And lastly, I'm from the Singapore office that handles the entire APAC region, that's China. My contact details are as follows. If you wish to inquire more, do feel free to contact me through email or WhatsApp. And I'm ready to take any questions if there are any now. If there are no questions, I can always wait to the end and take questions then. So maybe about 20 seconds if there are any questions that have been raised so far.
Okay, so here's one question for you. What are the agencies doing for wind farm maintenance after OEM service contract is over?
So they're talking about if there's after sales service, after we provided our service?
Yes, sir.
Yes, we do provide comprehensive annual maintenance services as well as on-site servicing as well. So if any point in time there are issues with our product at the site, we'll be able to repair them and swap out components accordingly.
Okay, okay, sir. And one more question: which type of technology should be deployed for energy storage?
I think for energy storage, our laser projection technology doesn't really apply in this case. Our laser projection technology applies for the blade layout process.
Okay, sir. Thank you very much. So pending questions, we'll be taking it over during the Q&A session. Thank you. Thank you for the insights, sir.
Thank you very much. I'll stop sharing my presentation now.
Yes, sir. So now we'll be moving ahead with the next presentation on global wind turbine technology trends by Mr. Shashi Badla, who is a principal analyst, global wind supply chain and technology at Wood Mackenzie. Over to you, sir.
Praveen, you're in mute. Can you unmute yourself?
I can, yes.
Mr. Shashi Badla, you are on mute. We are not able to hear you.
Yeah. Can you hear me now? Is it audible now?
Yeah, perfect. Thank you.
Yeah.
Yes.
Thank you. Good morning, everybody. This is Sashu Barla, and thank you all for joining the session, and thank you, Wind Insider, for inviting me to present at this event. For the next 9 to 10 minutes, we're going to touch upon some of the global wind turbine technology trends, and of course, with a little bit of flavor on in the Indian market as well. For those of you who are not familiar with Wood Mackenzie, we are a global research and consulting firm in natural resources sector. And within the renewables, primarily we're about 75 analysts cutting across the renewable technologies, sitting in the closer geographies and key renewable markets closer to the clients. And within the renewable space, we capture almost all the leading renewable technologies, and needless to mention, wind and solar are a large part of it. Nonetheless, we're also scaling up our efforts on some of the emerging technologies like energy storage, grid edge, electric vehicles, hydrogen and carbon, and so forth. In each of these renewable technologies, we are fundamentally covering the whole spectrum of the value chain, starting from upstream, that's the supply chain, and technology systems and operations and market dynamics. So you get a full view of the industry and present key insights to most of our customers across the value chain. With that, a quick introduction of myself. I'm Sashu Bala. I'm the principal analyst and leading the global supply chain and the technology practice at McKinsey for both the onshore and offshore segments. Spent over 11 years in the global wind industry, cutting across the different segments in the value chain, but lately is focusing on the upstream, that's a supply chain and technology. I'm based out in Aarhus, Denmark, working from the legacy Wood Mackenzie office, or the legacy make office. And without much ado, let's move on to the contents for the session today. And before I comment on the turbine technology trends itself, I want to draw your attention to the global market outlook. And my predecessor, Mr. Chow, has already presented a glimpse of it, talking about the global wind outlook from a Q1 update. So you already had a good overview of it. Now let's take a quick look at how the market forecast looks like for the next decade. I mean, for the folks who are around in the industry for some time would assimilate and acknowledge the fact that wind industry has been always a policy-driven market, and short-term is not an exception to this phenomenon. You can see from the graphic on the left-hand side that there is a surge in the installation activity in 2020 and 2021, and this is largely stemming out from the policy transitions in two of the biggest wind markets, that's China and the United States. However, if you look at the post-2021 period, you're going to see a kind of decline in the market stemming from these two, decline into these two biggest markets. Nonetheless, towards the later half of the decade, you're going to see that installations climbing up and largely attributed to the growth in the global offshore market, are, put in another way, let's say that globalization of the offshore wind sector, and as well as growth in some of the emerging markets. So you're going to see wind installations touching upon or surpassing the 80 gigawatts annual installation mark. All in all, if you look at, we're talking about 75, 76 gigawatts of annual installations in the next decade, compared to roughly 50 gigawatts in the past 5 to 6 years. So which is roughly 50% higher than what it has been in the past 5-6 years. And this 75 plus gigawatts of installations provides a critical mass for the turbine OEMs to innovate on the turbine technology in conjunction with the component suppliers. Now, talking on the turbine technology, if you look at the turbine platform positioning across different geographies, that's Americas, EMEA, and APAC, like I said in the opening remarks, that because of the policy transitions in some of these biggest markets, or a bulk of the global markets are transitioning to the auction mechanisms. Now, the impact it has on the product positioning is that in the next 4 to 5 years, we're going to see a convergence of the product platforms. So primarily in the markets like Americas and EMEAC. However, when it comes to the APAC markets, because of the low wind and ultra low wind speed regimes prevailing in these markets, especially China and India, we're going to see still a demand for a different set of product platforms with large rotors. Now, talking about these markets, let's take a quick look at the average turbine evolution. One is curious to see how the turbine technologies are evolving globally and as well as in India. I'll come back to the graphic on the left-hand side, but let me quickly comment on the content on the right-hand side. If you look at in the European offshore markets today, 8 to 10 megawatts is the current mainstream turbines that are currently being installed across the offshore European projects. And if you look at some of the commercially signed agreements or framework agreements today are based upon 12 to 15 megawatt wind turbines. And we project that these turbine sizes are expected to increase, and they're almost going to double by the end of this decade. So we're going to see an extremely large rotors and bigger drivetrain capacities in the offshore. And this phenomenon is no different in the onshore space as well. Now, looking at the graphic on the left-hand side, you're going to see that in the onshore space as well, the turbine technologies are expected to double in most of the regional pockets of the regional geographies. And even in India too, the turbine technologies or the turbine sizes are expected to increase, albeit at a lower level compared to the global and as well as the regional average. And the question should be, why is that the turbine technologies is growing at a lower pace in Indian market? And this is largely stemming from the wind resources availability. Now, if you look at on the graphic on the left-hand side, I tried to plot the global IEC turbine class positioning. Today, most of the wind markets globally are positioned with IEC2 and IEC3 wind class turbines. And this is strikingly contrast to the turbines that are positioned in the Indian market. If you look at the graphic on the right-hand side, you could see a large part of the Indian market is positioned with IEC3 wind turbines, and we are going to see the proliferation of the IEC4 wind turbines going forward. And this simply because most of the good wind resources have been already occupied by the legacy generation technologies. So for the new build installs, we would expect that turbine OEMs are likely to deploy the IEC3/IEC4 wind turbine technologies. Now, what does this imply on the components? And primarily the biggest component that's going to be impacted is the blades. Now, turning towards the trends in the blades, if you look at from a global onshore segmentation perspective, today, in terms of commercial installations, we're already seeing 60 to 70 megawatts blades is the current mainstream products. And just to draw your attention, this is on the turbines that are grid connected, not commercially sold. When it comes to the turbines that are commercially sold today, most of the global markets are already seeking 70 plus meter onshore blades. And the situation in India is also expected to evolve because today 60 meters blade length is the mainstream segment in India today. However, in the next few years, we're also going to see the 70 plus meter turbines being deployed in India. And a good example is a few weeks ago, we have seen Siemens Gamesa introduce their 3X 145 turbine. And a few months ago, Inox has introduced their the 3X 146 turbines as well. And Nordex Acciona is already historically positioned their 3 megawatt platform into the Indian market. So we're going to see a suite of other turbine OEMs positioning such kind of product platforms into the Indian market. And talking about the technology and some of the challenges that are very peculiar to the Indian market, of course, it's also a phenomenon in some of the global markets, but it's worth mentioning that Indian market would also face, or likely to face, some of the logistic challenges and constraints going forward, as and when we see the proliferation of the 70 plus meter onshore blades. And the industry turbine OEMs, in conjunction with the suppliers, are working on innovative solutions. And a great example of this innovative solution is the split blade technology. I would assume that one of my co-panelists, Akhilesh, is also present, and I would assume that he would also touch upon this. But nonetheless, I think we're confident that because of these logistics challenges, we're going to see that India would prove a conducive business test case to deploy the split blade technology and making it a commercially mainstream segment in the next few years. That said, I'd like to conclude the session by talking of some of the high-level themes that we're seeing in the global wind industry. There is an immense pressure across the value chain to reduce the levelized cost of electricity. That's in turn creating hyper competition within the wind turbine OEMs, and we're going to see a great amount of market share consolidation among the turbine OEMs in the next few years. And in order to address the demand, turbine OEMs are focusing on increased pace of new product introductions in order to be competitive in the market. However, bearing the cost in mind and at the same time addressing the customer demands with new product variants, there will be two inevitable themes going forward, and those are standardization and modularization of the wind turbine technology, components, and as well as the supply chain. So I would expect that these two themes would be a dominant in the industry for the foreseeable future. With this, I would conclude my session, and here are my contact details. So feel free to reach out, and if something calls for additional clarification, I'm happy to address now or at the end of the session. And over to you, Sangeeta. Thank you.
Thank you very much for the insight, sir. Now we would be proceeding ahead with our next presentation on wind turbine lubrication and reliability by Mr. Praveen Nagpal, who is the Chief Technology Officer at Shell Lubricant Solutions, Shell India. Over to you, sir. Mr. Praveen, are you there with us? I suppose we have lost Mr. Praveen's connectivity. Jyoti, would I request Mr. Ulf Ripper to please take it forward?
Yes, Praveen is joining again. So let's just wait for him to come in.
Perfect. So meanwhile, what I'll do is, Mr. Chow, we have received a few questions for you. If we can take up those questions. Meanwhile, Mr. Praveen is joining us.
Okay, sure.
Hey, morning all. Can you hear me?
LAP helps to achieve more accurate blades with minimum error and maximize resource utilization, thereby more blades production. Can you please elaborate with this?
That is correct. As I presented earlier in my slide, the laser projector will be able to show all necessary alignment lines onto the blade mold. So there's no need for measurement or doing marking by the operators, which takes up a lot of time. Sometimes these markings and measurements, if they're done manually, there might be some errors in this, and then the blade itself might be produced with some errors inside, and maybe possibly scrapped. So just by following the laser lines, which are very accurate and to millimeter accuracy and drawn to scale onto the mold, operators will be able to do the layup of the blade much faster, significantly faster. We experience some 25 to 30% improvement in blade layup time. So that's the time savings that people can expect, as well as because of the minimized error, because of the lines are so accurate, there'll be less chance for errors to be made by operators in their layup process, and that will help to avoid costs of any blades being made wrongly or being scrapped or and failing prematurely. So these are the benefits in that way.
Thank you very much.
Besides that, also operators can then be freed up from the job of making markings and measurements and be deployed elsewhere to do other tasks. And it also helps with the training of new staff as well, because all they need to do is just follow the laser line. They will be onboarded faster and be able to help in production at a faster rate.
Thank you very much. So we have Mr. Praveen who has joined us. So I think we have again lost his connection. Jyoti, is Mr. Praveen joining us back? Okay, meanwhile, while Mr. Praveen joins us, I believe he's having some technical issues at his end. I would be quickly launching few polls.
Yeah, Sangeeta. So there is some connection issue. In the meantime, we are just setting it up. He will join via phone. And,
no problem.
One of us will be presenting the screen. Yeah?
Do you agree launch of 3 megawatts plus platforms is required to ensure competitiveness of wind in India? I'm closing the poll now. So 55% of attendees agree with it, strongly agree with it. I'll quickly move on to the next poll. Do you agree that digitalization of already installed wind turbines is required to ensure turbine reliability in long run? I'm closing the poll now. So 64% of attendees strongly agree with it. Thank you all the attendees. So one last poll. What percentage of wind assets do you see completely digitalized in 2025? I'm closing the poll now. So 25 to 50% is the percentage that 41% of attendees agree with us. Thank you all the attendees. We'll just wait for Mr. Praveen sir to join us. He's facing some technical issues at his end.
I think just to bridge the gap here, I think I see a question here on the blade lengths in the Indian market and how we can accelerate to 80 to 90 meter blade lengths. I think one of the fundamental issues that we got to face in mind is technology is not a limitation, so to speak, and the real limitation is the cost of technology. And the ability to deploy these longer blades would come with additional cost. And once we reach the critical mass of these blades in the global markets, and this would also percolate down to the Indian market, and that's one thing. And the second second thing is, of course, if companies will be able to crack the split blade technology and cost effectively develop the solutions addressing the weight concerns, we shouldn't see a reason of why why the split blade why the longer blades deployment should halt. Having said that, the other dimension that we got to bear in mind as well is the tip height restrictions that we face because of these large rotors and taller towers. Some of the markets, you need aviation clearances for the radars, so it's not practically feasible to deploy these taller towers and longer rotors. So that is also something that we got to bear in mind. And here in Scandinavia, we're going to see, in Norway and Sweden, most of the forested terrains which are not constrained by these kind of regulations. You're seeing large rotors and taller towers being deployed. So I would see that once if these issues are addressed, then it should be relatively easier to deploy these technologies, or the latest generation technologies, so to speak.
Right, sir. Thank you very much. Thank you for taking up that question.
No problem.
So Jyoti, coming back to you, is sir joining us?
Yes, he's just trying to join via phone.
Perfect.
Yep. In the meantime, you can take up a few more questions.
Okay. So in that case, I'll hand over the session to moderator. Sir, you can address few questions to the panelists that we have today.
Sure. I'll just like to have ask a question to Mr. Cho. Cho, you talked a lot about this blade lay processing and other things. How do you think this process will help in the service phase of the turbine?
In the service phase, when you're talking about as in repair.
Yeah, once the turbine is installed and in operation, do you think this process is going to help them?
It would not be able to help in that service process. The way the laser projectors are installed in the factory itself, and needs to be set up above the blade more. Once the blade is delivered out of the factory, the laser projectors wouldn't be able to perform that purpose anymore in terms of servicing the blade if it's, let's say, repaired or on site at the farm. It's really meant purely for the blade layup process and a guidance tool, an alignment tool for operators during the blade layup itself.
Yeah, that's nice.
Okay. I hope that answers the
question. Yes. Thanks, Cho.
Okay.
Yeah, Sangeeta, over to you.
Yes. So Mr. Praveen has joined us. So over to you. You can continue with your presentation. Thank you.
Thanks, Sangeeta, and thanks, Jyoti. Sorry for this technical glitch. My connection dropped twice.
That's absolutely okay, sir.
So, morning, ladies and gentlemen, and thanks again, everyone, and thanks to Windsight for giving us this opportunity to present the technological development happening in the wind turbine lubricant sectors, especially from the reliability aspect, total cost of ownership, and the sustainability point of view. Now, both of the earlier presenters actually talk about the role which wind power is playing significantly in the cleaner energy. And I think as the wind power has gained attraction across the world, lots of effort actually made by the OEMs to make wind turbine more reliable, more competitive, and which has resulted continuous evolution of wind technology. Now, if I really talk about, can you see my slide?
Can.
Okay, just can have some issue with moving the slide. Maybe Jyoti, if you can present the slide because I have some challenge.
Sure. You have to,
Yeah. So while Jyoti actually run through the slide, and I talk about the slide number 3. If we really look from the OEM side, the effort has been made in the wind turbine, especially I think the two aspects. which is causing the revolution in the wind turbine technology. One is the demand for the higher output turbines and the efficient turbine. That actually has resulted in the change in the design as well as metallurgy of the components. For example, we talk about the compact gearbox design, uses of plain bearing, which allow design flexibility, especially the compact design. Now, on the other side, if I really look at the design life of wind turbine, now some of the leading wind turbine OEMs are already calculating the 25 plus years of the design life, which can be extended further. Now, it used to be like 20 years, but to my knowledge, many of the wind OEMs are already ready with the prototype, which can actually give the 25 years and looking further to extend the design life of the wind turbine. Now, as the technology of the wind turbine evolved, so the lubricant for the wind turbine, and that's primarily focused on three core needs on the wind turbines. One, as I mentioned, is the reliability aspect. Second is reducing the total cost of ownership. And third piece is sustainability. Now, with the technology upgradation with the turbines, the challenges for lubricant also has increased. So earlier, when you look at the typical issues which are raised in the wind turbine, more were around the micro pitting, rusting, foaming. Now, these were the major challenges from the industry. Now, if you really look at the current stage, especially for the new generation turbine, the more focus is on the contamination, the yellow metal corrosion, and at the same time, the foaming is still remain a major issue. And we try to validate this feedback. We connected to 100 plus wind turbine operators, end user, as well as the OEM. And that's evident. Like if you look on the screen, now this is the survey we have done across a number of customers to understand what are the primary challenges they face in the lubricant perspective. Coming out very clearly, these three areas are the biggest concern for them. Now, Jyoti, if you move to slide number 4, now unlike conventional lubricants, if you really look at the wind turbine oils, they need to be co-engineered. You can't have off-the-shelf pack-based lubricant which you can use in the wind turbines. So you have to basically ensure a co-engineered lubricant which provide you the gears and bearing protections, compatibility with the seals, paint, and the components, very, very critical from the reliability perspective. Then the wide operating range. So you can find the wind turbines are commissioned at a different ambient condition. Somewhere the temperature can go as low as minus 30, but then you also have a wind turbine operating at 50 plus ambient condition. And however, as mentioned earlier, these three core issues which are most relevant from the lubricant reliability perspective are the yellow metal corrosion, contamination, and the foaming. So, Jyoti, if you move to the slide, next slide. Now, when we start working on the next generation lubricant, we anticipated the challenges which can come up with the new generation higher output compact turbines. And what are the primary core needs of the wind sector? We start closely working with wind OEMs in developing a product, Shell Omala S5 Wind, which is a main gearbox oil, and that product actually has helped maintain the foaming performance, which I mentioned is the core issue in the wind turbine oil sector. Now, even with the extensive filtration cycle, we look at the performance of Omala S5 Wind. Now, the industry standard says if you complete say 1,000 filtration cycle, the oil is good to be used, a typical industrial gear oil.
I'm sorry to interrupt in between, sir, but then we have got requests from the attendees saying that they cannot view the slide clearly. So, Jyoti, can I request you to please make it full screen?
Jyoti, please go on display settings and switch screens you show.
Okay. So meanwhile, when Jyoti make it full screen, I continue with that.
Perfect. Thank you.
Is it better now?
Thank you.
Yeah. So I was referring to the filtration. A typical industry gear oil goes through the 1,000 cycles of the filtration. While in case of Amala S5 wind, we actually stretch a lot. So we went to 50,000 cycle, which is close to the oil lifetime of the oil, and still we find the condition of oil is very good. And this is developed with unique combination of high performance synthetic base oil, so which we say MPAO, and the additives, which actually improve the cold climate startup properties and the air release property, which is very, very critical from the reliability aspect, because if there is too much of air left out in the lubricant, then it results in the cavitation on the gears. Now, its extreme stability against oxidation help in increasing the oil life, and then that actually give us the confidence. And due to that reason, this product actually comes with the 10 years oil life warranty, which help in reducing the total cost of ownership for the user. And Shell Amala S5 wind, we have tested in the harsh cold climatic condition, which has shown the better fluidity, even the extreme conditions. So if you really look at the pictures here, you will find a typical gear oil when you are doing the cold chamber testing. It's choked completely, it doesn't flow. While the Amala S5 wind has been tested even at a minus 40 degrees centigrade, and then you find the oil is still very fluid. So it's the flowability in the system ensure each component of the wind turbine is completely lubricated. And most importantly, which I said, the perennial problem is the yellow metal compatibility, and which makes already suitable for the broad variety of plain bearing materials. So Jyoti, if you move to the next slide, here I talk about what do you mean by the yellow metal compatibility performance. Now, if you really look at the industry standard, when we look at the corrosion, now these are not sufficient. Now, these standards actually can't tell you which product has a better performance in terms of yellow metal compatibility. And that's where we brought the Discovery Hub experts from the Shell technology to create a new standard to test the oil in an extreme condition to ensure the customer or the end user or the OEM doesn't face any yellow metal compatibility issue when they look at increasing the design lifetime for the turbines as well as for the extending life of components like bearing. A typical ASTM test, when we do on the corrosion, doesn't reflect the issue which we have seen in the last years on the yellow metal compatibility, which produce the varnish on the bearing cage of the gearboxes, which is typically running for 4 to 6 years. And therefore, we have developed a test method to differentiate to products showing issues with the yellow metal issue, like the product which can actually perform well and the product which cannot really work for a longer period when it comes to the compatibility. So what actually we have tried, not to test only a fresh oil with the typical ASTM corrosion method, we make it more severe. We oxidize the oil in presence of the catalyst, especially the combination of copper and zinc, which is making it really, really kind of a poison for the corrosion. So we have tested the lubricant, oxidize it, and then run again this corrosion testing. And on the slide, you can clearly see the performance of Amala S5 wind. So many of the oil which has failed. Now, typically, if you look on the corrosion test, the presence of a material like copper and zinc has to be, say, less than 5 ppm. But then you can see in certain cases, the copper and zinc is going as high as 60. I mean, it's actually going to kill the turbine completely. And while as Amala S5 wind, when you see the copper level is typically 1 ppm, so it's insignificant. So even if the oil has been oxidized and then there is a high tendency of increase of copper and the zinc on the oil, which can actually create a lot of issue around varnish buildup. It actually acts as a catalyst, also reducing the oil life. Amala S5 wind address these issues completely. So ensure for the future generation turbines, the solution is already there in terms of the reliability. And the last thing which I want to touch upon Omala S5, so Jyoti, if you move to the next slide, is the sustainability aspects, which I touch upon. Now, when I talk about the sustainability, now we look here, when we talk to our customers, whether they are in the process industry or in the power sector, each of the customer actually has a sustainability target. So everybody is moving towards the greener. And I think this is inevitable. The future, if we have to survive in future, if we have to give a cleaner future to our next generation, we need to ensure we increase the cleaner energy and find a way how we basically increase the green footprints across the world. And the uniqueness of Shell Omala S5, it certifies as a carbon neutral product. And when I say certified as a carbon neutral product, it offsets any of the CO2 emission produced during the manufacturing of this product with the nature-based solution. And when I talk about the nature-based solution, it's more about the plantation, forestation, changing the grassland. And that's where we actually support the OEMs and end user on offsetting their CO2 footprints, which might be happening in the other processes. But with the use of this certified Omala S5, this helps in offsetting those CO2 footprints. So now, taking not much of time and concluding my presentation, I would say wind turbine technology and the solution continue to evolve. And I think that decade is a good example. We have seen it has a significantly changed. So we look at now the next generation turbines, and as Shashi mentioned and Mr. Chow mentioned, the increasing number of turbines on the offshore. We are talking today the floating wind turbine. We are talking about the increasing design life, 25 plus year. So conventional lubricant cannot address this. So you really need to solutions which are co-engineered, integral to the system design, which actually handle the technology severity, help customer reducing their total cost of ownership, improve the reliability, and also bring the sustainability footprints. And what I can say on the Shell Omala S5 wind, it's a revolutionary turbine oil that addresses the core of wind power. It has approval from all leading major OEMs, or we talk of the component supplier, and accumulated already experience of 750,000 operating hours across the globe. And worth mentioning, about 1,000 plus wind turbines in India are already lubricated with the Omala S5 wind. And in summary, I would say while the technology for the cleaner solutions continue to evolve, we are fully geared up to develop the new solution for the clean energies. Thank you. Welcome any question if there are.
Sir, I believe Jyoti was supposed to share the last slide, which was pending, wherein she couldn't share because of some connectivity issues. So I request my colleague Ajas, if you could just share the last screen, because I think Sir was presenting and that time she lost her connectivity. The last slide, I suppose it was pending. So this is the slide that you were talking about, right?
Absolutely. Yeah. Thank you.
Perfect. So I just wanted to show it across to the attendees. Yeah. Thank you very much, Ajas. Thank you. Thank you, sir. Thank you for your insights. With this, we will be proceeding ahead with the panel discussion session. The topics of panel discussion that we would be covering in today is latest technology in wind turbine manufacturing and design to increase the process reliability, enabling adoption of fastest predictive analysis from wind turbine, technologies for reducing wind turbine downtime, advanced blade designing and manufacturing technologies, next generation wind turbines, engineering and hydrolytic solutions to wind turbine failures, the changing phase of wind turbine servicing and maintenance. So we have industry experts joining us today. starting with Mr. P. Rajendran, who is a Vice President Service at Siemens Gamesa, who would also be moderating today's session. Mr. T.K. Chow, who is the Regional Sales Director APAC, INDP from LAP Razor. Mr. Alok Kumar, who is a Country Head at DNVGL. Mr. Hulf Reper, who is a Production Application Specialist at Shell Lubricant Solutions. Mr. Amar Trambadia, who is an AVP Engineering at Semcorp. Mr. Akhilesh Mishra, who is a Senior Director, Center India at LM Wind Power Blades Private Limited. Mr. Bharat Kumar, who is a Wind SGV Head at Greenco Group. I request all the speaker panelists to kindly switch on their cameras and unmute themselves. And Mr. Shashi Barla from Wood Mackenzie. Thank you very much. I now hand over the session to moderator.
Yeah, thanks, Sangeeta. Ladies and gentlemen, very, very good morning. Though there are many challenges now, right? It's either because of COVID, regulatory, or other issues. One thing is very clear: the prospects for the wind industry in the long term looks very positive and it's very strong. So the good days are just waiting to come. And this as a context for today's discussion, we have a very good list of topics ranging from present to future technologies, next generation wind turbines, turbine reliability, changing phase of wind turbine operation and maintenance, predictive analysis in the wind turbine operations. So they're very good topics. And we are very fortunate to have a good mix of experts representing various sections of the wind industry. And like you all, I'm also very eager to listen to their views and learn from them. I feel very honored to moderate this session and thank First View and the sponsors for this great opportunity. So let me tell the design of the program. So since we have a lot of experts, what I will do is I will just start asking one question each to each of the panelists and set the tone for discussion. And end, depending on the time, we can discuss more on the common topics, and also we'll have time for the question and answers. So let me start with the, so we have the panelists representing the investors, that is the very large independent power producers like Greenco and Semcorp. And then we have people from the oil lubrication sector, that is the Shell Lubricants. Then laser measurements, Mr. Chow is there. Akhilesh is there on behalf of LM. And then on the risk management and quality assurance, yes, Alok is there from DNG AVL. So let me start with asking the questions to the investors because they provide us the bread and butter. So let me ask the first question to Mr. Bharat. Bharat, you have been managing wind assets of more than 1.5 gigawatts. We would like to hear from you, from your experience, what should be done to improve the turbine reliability and what changes are required with respect to the engineering services which are offered by the suppliers like LM or the OEMs, like all the OEMs or the experts in the laser measurements and the lubrication industry. So we'd like to hear their views, Bharat.
So you'll have to unmute yourself.
Yeah, thank you, Rajendran. First of all, let me thank the Wind Insider and the sponsors also for giving me an opportunity to be part of it. And as you rightly put that, because we've been operating that we have more than 2 gigawatt with multi turbines and multi technologies and multi models. Okay. So we would see that to improve the reliability and fundamentally the engineering services. As you all know that the output of the turbine has it's increased in the last 5 years to a decade from the PLFs crossing more than 25 to 30, 35 and 40% now. So it is also causing a good stress in terms of the turbine and the service system, service and technology to give the best reliability, okay? Because everybody looks at it, because from an investor point of view, always people look at what can always be the maximized, okay, in terms of it. So a couple of things that which always comes into our mind, and then the current trends also which been happening is to improve the reliability. The fundamentally it is going towards the current predictive practices. Okay, so in many of the places, it's like today's scenario is a very highly centralized predictive analysis on a remote basis or on a remote basis. But as such, now the capacity has spread across to so much of the region. This need not be so centralized, and it can always be a decentralized predictive analysis in terms of a real time. Okay, with a new smart initiatives. Okay, it need not be a conventional and traditional condition based systems. There are new initiatives are coming these days, which been very versatile. Even many of the process plants that will always give a very good reliability to the turbine. Let it be a breaker, let it be a generator, let it be a gearbox, let it be even to the blades. Today, so many extent, the reliabilities on the blades are, the monitoring mechanisms are very limited at the moment. So if we can bring this will be definitely a good scope for improving the reliability. And also, we also could see is because today's buzzword is the digitization of everything. Okay, so with the bandwidths increasing from 2G, 3G, 4G now to the next 5G, 6G levels, so there is a good scope for analyzing this data, and with the good AI practices will give, because I don't know that how far it is going to be, but these are all definitely going to be the future practices to improve the reliability. And the good engineering services as today, because the wind farm is set up and then it operates on its own set of parameters. Okay, a dynamic adjustment of the wind farm through an artificial intelligence software programs, okay, which can definitely help in terms of its own AI alignments and pitch system controls and analyzing the performance will always definitely will give a good improvement with respect to the services, because the turbine is performing. It's not that the turbine doesn't perform. It also calls for a real-time tuning. So what best that it can able to bring. Okay, so that dynamic tuning as on date, the tools are in European market or in American market are little bit, it's an isolated places that's been happening. But if these tools are made available to the Indian segment, naturally, then you can see a good performances that which can come out of the wind farms. Okay, and coming to the services, the whole services today, the dire need is because the turbines are designed and manufactured with certain base with some with other continent design characteristics, and when we've been doing it to the Indian continent, which itself is quite different and variant. If we adopt the purely the local Indian design before the turbine is going to put into the commercial, so that will definitely give a very good result for the performance. Because today, as you look at the guys who are all talking about 20 plus years, people are talking about. Okay, and this will definitely will help. That's what I could able to tell you to the forum and to the people. Yeah.
Right. Thanks. Thank you very much, Bharat. The summary, the good points come, and we will summarize at the end. Next, I will just move to Mr. Amar. Again, he's from the investor side. Mr. Amar, one of the key performance indicator, what we normally measure as a OEM is we call something called as the MTBV, the mean time between visits. And what is your view, since you head the technology, and what is your view on how we can actually improve the overall troubleshooting process, how we can shrink the troubleshooting time, and what is the role of digitalization in this? And as a company, right, in SEMCOP, what is that you're doing?
So good afternoon and good morning to all of you. Thank you, Mr. Raj, for bringing me on to the discussion, and thank you for the sponsors and Wind Insider. Yes, sir. The MTBV is every time a first turbine faults and person has to travel. So this loses the operational time of the turbine. When we lose the operation time of the turbine, so company IPP who has invested, they lose the generation, they lose the money. So digitization, what I see is digitization is a buzzword, as Mr. Bharat already mentioned. This brings all the data to a place, and a right amount of analysis of the data can give you what could be the improvements we can bring to the turbine, to the wind farm, and reduction into the visits to the turbine, that is MTBV. We increase the number of MTBV, will always improve the production levels of the turbine. So that's one part of it. Now, second part is digitization can bring all the data. You can have 1,000 turbine data, but you need to have a right tool to analyze it. It should be tool on a value based, not on a number of tools. You can have a number of reports. If it doesn't add value to improve the performance of the turbine, it doesn't help. Then third thing, for the troubleshooting part, the digitization can help in a real time. A technician going to a turbine for a stop turbine, he can have a ready-made information on his laptop, which can give him the tips to where he should be looking for, because every time an expert is not available, it is in a remote place, a turbine is stopped, he can have an expert tips for what he should be doing, where he should be looking, which reduces the amount of downtime to the turbine and which can improve the productivity in the end. So then third thing is, yes, you can bring, with the digitization, you can bring everything at a single place, but bigger is always not a better. So it should be the quality of data what you bring into the system for the analysis. It's very important that we bring in the quality of the system, quality of the data. Digitization also brings what we call about normally in the industry is a SCADA. It also bring in it should be digitization before digitization. It should be not like that. A person in the site is running around to collect the data and upload into the server. Then the digitization works. It should not be that way. It should be everything should be connected end to end. So that would help to reduce the downtime of the turbine, increase the MTBV, and increase the productivity of the turbines and wind farms. Third thing, last thing I would touch upon is, with this newer artificial intelligence building, with newer tools coming into the market, coming into European markets, a lot of place there, it's available. So it's possible. Right now, OEM gives a standard product with standard sets. So with different sites, this product can perform better at one site with some different settings, and it can perform with a different setting. Other side it can also improve the productivity of the turbines, and which I would say possible with this new digitization world and SCADA, what we have with the newer versions. So OEM should be looking into that as site-specific solutions for the customers.
Thank you. Thank you very much, Amar, for the valuable inputs. Next, we will move to Mr. Wolf. Wolf, I just want to understand from you, what is the role of lubricants in improving the turbine reliability? Is there a way where we can quantify that? That is one. Second is how the technology is evolving, because wind turbines, you actually see that it's getting bigger and bigger. So how the lubrication technology is evolving with the changing trends in the wind turbine design? I think Wolf, you had to unmute yourself. We couldn't hear you.
You're mute.
Yeah,
Sorry. Sorry
yeah.
for that. Thank you for reminding me, and thank you for the invitation. I think there is still a lot of things to do, and Praveen has already explained that there is a trend towards bigger turbine, higher reliability, and I think it was a very good question to see this mean time between visits, and especially by developing new fluids which can extend the maintenance intervals. We do something to reduce total cost of ownership. So like when you see mineral oils have been exchanged after 3 years, you see synthetic oils, the first ones after 5 years, 6 or 7 years, and then we are giving the oil life warranty for 10 years. So you already see that you reduce the number of visits at the turbine. It makes us as well, due to the reliability of the products, to reduce the maintenance intervals. If you combine that with bigger filters or other on the grease side, if you combine things to move from 6 months to a 12 months maintenance interval, I think a good performing oil and greases can help here. And it's difficult to quantify that because that depends on the turbine and how you do the current maintenance interval. That's one point. And as well, the reliability and how the oil is handling the equipment. So you have seen, for example, issues in the field on micro pitting earlier, but now compatibility becomes more of an issue, and you have to make sure that the oil is performing in the whole oil life and is not harming the equipment. And that is something, and more things will come. So when we talk about digitalization, you will have electrical parts in the gearbox. So further compatibility have to be tested. So that's a broad range of tests to be conducted, and we are happy to move with the OEMs to work on new requirements and adapt that to our portfolio and collaborate on that. So I think that's the biggest point and the biggest part we can play in that. And it's not only new gearboxes. This can as well improve the total cost of ownership for older gearboxes or in-service gearboxes when you just change the oil to a better performing product.
Yeah, thanks, Wolf. One more question. See, what often I hear when we discuss some new orders with the customer, there is always one topic which I would say that neither the investor nor the OEM takes decision. What do you feel about the auto lubrication systems? Do you think it adds value, or what is your views on that?
You mean especially auto lubrication system for the greases?
Yeah,
right?
greases. Yeah, mainly for the greases.
Yeah, I think that's a key thing to extend the maintenance intervals. If you don't do that, you have to bring people up tower, and that doesn't really help. And the auto lubrication systems are widely used, and I have no issues with that. If you adapt the product towards to it. So when you go from manual lubrication towards automatic lubrication, you have progressive distribution systems. So the grease have to be fit for purpose for that. So that is a key thing. So that not just old or greases which have been used for decades are continue to be used, but that as well the industry is looking if there are new requirements
that they can quickly adapt new technologies. And I think that's something where we have to improve, is that the reliability steps can be put in when we quickly adapt new technologies.
Right. Thanks, Mr. Wolf. Next, we will move on to Mr. Akhilesh, and then maybe Cho can also answer the same question later. Akhilesh, one of the biggest challenges what we face today is on the blade maintenance, right? Whenever there is a lightning or handling damages of blades at site or the wind farms, it normally takes a lot of time for us to do a repair of the blades at the wind farms. Do you think modular design concept is possible in blades, so that if a middle portion of the blade is affected because of lightning or a tip is damaged, can we just remove those parts and just fit the module and then keep the turbines running? Do you think a possibility of doing that going forward?
Yeah. So I think first of all, thanks everyone, and thanks to the forum for giving me this opportunity to share my views. And I'd say good afternoon, everyone. And so I think that certainly that's a very pertinent question, which has been facing the industry for a long time, and there have been efforts uh, by the different, you can say, blade manufacturers as well as the OEMs on looking at the modular blade concepts. And I think the one thing which was talked about by Mr. Sashi and later on by others, is that as the industry is seeing the demand, especially in the low wind speed regions, for higher diameter blades, and it is certainly making the existing technologies of blade manufacturing, if we follow the same, the blade will be a lot heavier, and it will also have more noise. So it is just that the coming in from that industry demand, where previously you were having a blade sizes of 40 meters, and now in India we are talking about 70 meters blades, and maybe even 70 plus meter blade. And how do you logistically get these blades out to the place where it needs to be installed? So it certainly requires modularity. So maintenance is one aspect of it, but I am saying that from the design feasibility perspective, utilizing the floor space in the manufacturing area where you are making the blades, and then also customizing the product for the different geographies. So, and if I can use the word from the show, that if we dream of a product where there is a, you can say, a generic, a bottom portion of the blade, and then there is a tip which is, you can say, can be customized to different regions for different lengths, with a different kind of tip abrasive solutions depending upon the kind of durability requirements which are there, or any leading edge protection requirements which are there. So this is something which GE has been working on basically, and LM is part of GE. And so we have been working on a jointed blade concept, and like roughly around, I would say, say in a say 76 meter blade, around you can say at 60 meters, you can think of having a 16 meter tip and a 60 meter root, and then having a jointed mechanism which is patented by GE. And this is something which is certainly on the product launch, is coming soon for LM. And this is the technology which we think will help out on the, you can say, the manufacturing as well as the transportation, and then on the maintenance, where you can do the on-site maintenance of the tip replacements on the field. And just the specific, the question Mr. Bharat has talked about that there are very few solutions on the blade maintenance and our ability to detect the damages. And this is something which I would say, this is where I would say industry needs to come together using the modern days image processing tools. And so there are organizations which we have seen where through the drones they are capturing the images, and then they are kind of processing those to detect any cracks. This is these are the concepts which are need to be, you can say, matured. And as of now, I would say as a team we are not working on these, but we are actively looking at all these concepts. And I think it will certainly help to up our maintainability on the blades in field.
Thanks, Akhilesh. Mr. Cho, you want to add something? I also want to understand the process, whatever you said, the blade lay process. Can it be applied for repairs which we do in the wind farms?
Okay. I would just like to explain that the laser projection technology is really meant for the blade layout process and not really so much for repair on site of the blade. It either be in situ at the blade farm or elsewhere. I can share though some other just based on knowledge wise from the aerospace industry, that for some of the blades, for composites, for example, for aircraft, should there be any damage to the composite surface, be it by lightning strike or bird strike, and there's delamination. There are tools in the aerospace industry, composite industry, such as heat blankets, heat bonders that can be used to repair composite materials and composite surfaces by using the heat bonders to apply the material, and then using the heat bonders to cure the material and repair that composite surface on site. So that's another form of technology that could be used to help repair wind blades on site on the wind farm. But it's not something that the LAP provides. Just to maybe add on to what Mr. Akhilesh had said, that the wind blades are getting larger. LM Wind Power is one of our customers as well from LAP. We are providing our laser projector technology out for the wind blade layup for LM Wind Power blades. For example, one of the ones that is taking place right now is the 107 meter blades in LM Wind Power in France that we are providing our LEP laser projectors for as well. So just a shout out to LM Wind Power, and it was nice working with LM for this.
Right. Thanks, Chow. And now let's move to Alok. Alok, you have a unique opportunity, I would say, to work with different OEMs as well as the investors on different assignments, because DNV being a risk management and a quality assurance company, your exposure to the OEMs and investors is much larger than all others. So what is your views on the next generation turbines, and where are we heading to?
Yeah, thanks, Rajendran. True that, we work with OEM investors, IPPs, so almost, all the major actors from the wind industry. And we have been in the industry for more than 30 years. So, right now the focus is on to reduce the cost wherever it is possible. So the first target was the extra design margin that the wind turbine had, because the initial first generation turbine design, it was quite over designed because it wasn't much understood, and these structures, even in those times, they were quite large structures. People had a certain fear and they didn't want it to fail. So that is one, like, the design optimization that we are seeing in most of the cases. Second thing, the innovation is happening in the areas, because now if you see the sales life of a new model is very, very short. You launch a new model and then you have to come up with another new model in next couple of years. So therefore, all the design tools, modeling tools, a lot of research are going on in coming up with such design tools, which are quite fast, cheap, and they reduce the design time. For example, we are involved in designing of one such tool that will reduce the time and will also increase the reliability of vortex-induced vibrations. We are working with IIT Madras in these areas. Thirdly, so far we looked into the optimizations of individual wind turbine. Now, what a lot of research is going into is like optimizing wind farm as a whole. If you see the micrositing, we don't have luxury or possibility of changing the wind turbine location. So your wind farm as a whole is optimized only when wind is coming in one particular direction. When it is coming from a different directions, then it is operating in a non-optimum conditions. So people are working to come up with a software. In one such research, we are also involved, that will look real time into the input for each individual turbine. It will, sort of model what would be the production from each individual turbine. And after that, it will try to maximize the generation of wind farm as a whole. And then it will send a sort of command to each individual turbine that will look at the optimum output from the wind farm as a whole. We discussed a lot about, that the sizes are going up, like going for the longer rotor diameter as well as the hub height. So it will continue to go, and because law of physics will not change with the sizes. So the limitations would, of course, come up in terms of restrictions from logistics, be it manufacturing, be it transportation, or be it installation. So a lot of research nowadays are going on in these areas, how to transport a large longer blades to a site, or how to manufacture a longer blades, or how to install that. So these are also areas, logistics side, where a lot of research are going on. We discussed about the modular blades as well as the split blades. I was involved like in 2007 working for a split blades, and I can tell you that, technically it is quite challenging because of the change in a stiffness wherever you are kind of joining it. And secondly, it's so sensitive with the structure, because a slight change in the, in the orientation, even in terms of minutes, will mean a, significant deflection at the tip. So rather, I see a lot of research going on in the direction of manufacturing the longer rotor blade and then bringing it to the site. So these are the few areas I see where research and innovations are going on. Some of the radical changes or radical innovations that are still going on are like coming up with magnetic gearbox, or coming up with the superconducting material. One more areas I would highlight, that now since this wind farm, first generation wind farm, they are very near to completing their 20 years lifetime. People are also incorporating concept of circular economy or recyclability. And from this perspective, some of the manufacturing changes are coming up. For example, if I again take example of blade, instead of typical epoxy resin or other thermostat, people are now talking about the thermoplastic, which will be more friendly in terms of recyclability. So these are the small changes which we see, and in next couple of years we will be seeing them incorporated in the manufacturing process as well as in the design. So these are the changes that we see, which will certainly reduce the cost and also improve the reliability.
Thanks, Alok. I just have two questions, one to Wolf and other to Kilesh and Cho. This is mainly with regard to the reliability of the turbine. So once this gentlemen answer these questions, and then I'll leave the floor to the panelists, and each panelist will have an opportunity to ask a question to the other panelist. So Wolf, to you now. With respect to, there are two major risks, right? When we say that the turbine fire, when there is a fire in the nozzle, there is oil in the gearbox, and there is also a hydraulic system. So two types of oils are there. And in the event of fire, right, these lubrication oil, can it act as an retardant rather than fueling the fire? Is there a possibility to have some mix and converting the oil itself as a retardant?
I think that's quite difficult because we are talking here about carbon products, so they will always they can always burn, and you know, this is in the steel industry. You are using fire resistant or less flammable products, but you see in these applications that these products have less performance in the application. So it's always a balance of, do you want to reduce the performance and maybe have even shorter oil lives compared to mineral oils? So we move backwards, as I originally explained. So I'm quite unsure about if this is the right way to move to water-based products, which then come with different issues like corrosion and other areas.
Right. Thanks, Ulf. And now the question to Akhilesh and Mr. Chow. See, as far as the blade is concerned, do we have is there a possibility to develop a monitoring process? Because we have sensors, we have other instruments which can monitor the other components of the turbine, right? For example, if you take a gearbox, we can know what is the oil temperature, what is the impurity level. So a lot of factors are available. But blade, as far as the blade is concerned, we don't have much. Right. Is there a possibility to have some monitoring mechanism which can tell us the performance or the condition of the blade real time?
I wouldn't be able to answer that question. I think that it'll be more catered towards the blade manufacturers to answer that. Is Mr. Akhilesh still there?
Maybe Akhilesh has some problem with the connection. So now, panelists, now let me start with Bharat. Bharat, do you have any questions for any other panelist?
As in now, I'm fine. Not much.
Okay, thank you.
Right.
Amma, you want to ask something to the other panelists?
Yes, sir. I think I would like to ask you about what is the OEM's future plans on improving the troubleshooting help, like inbuilt into the turbine control system. That's one. And the second is the OEM planning to make machine learning into the turbine control software to improve the turbine performance by itself by learning the operation criteria of the turbine?
Yeah. See, as far as the industry is concerned, the way in which the turbines are being operated and monitored, and even the business model itself is going a lot of change, right? Most of the customers are thinking of own operations. There are a lot of competition coming on. And as a OEM, the only difference, only value creation or only value addition which we can make is the use of technologies like AI, machine learning. And that is where we got a real edge. And a lot of research and a lot of projects are going on. Definitely, you will start seeing all this in next 2 years' time. And for example, we are developing certain robots which can do the blade repairs. That is one. Then the foundations and the blade monitoring, like the questions what we asked, we are also working on that. And then we are just seeing whether can we see now the grease analysis and the oil analysis, we just do it on a periodical basis. Is there a way that we can also bring those things to real time and do something. And the machine learning, yes, a lot of machine learning and this robotic process automation is going on. And most of the, in our control center in Denmark and other things, already this robotic process is already there. And most of the signals it automatically analyzes and it gives takes action, and there is very less of human intervention. Yes, definitely this is the area which the OEMs are concentrating going forward. Thank you very much.
Thank you, sir. Thank you for your answer.
Wolf, you have any questions to the other panel members?
I do not have a direct question, but it's more about we are here a team of people trying the OEMs, service, and component manufacturers or oil suppliers, and with all this digitalization, like what you explained, monitoring performance of the components, and maybe even in the future monitor the oil performance. How do you see sharing those with the component manufacturers? So like when you are monitoring the oil performance, sharing that maybe even online with the oil supplier, so that both parties can help the total, to reduce further the total cost of ownership, optimize more the system. So moving, do you see a trend on moving back? Hey, this is my data. So this is Siemens Gamesa data, or this is a service provider data, and saying, hey, this is freely accessible for the participants, so we can all improve the whole system.
See, as a OEM, if you actually see, yes, they were OEMs were restricting data earlier, but I don't see the trend is fast changing. Even most of the customers have access to most of the data, and we are quite open, because the common objective is to improve the reliability and maximize the yield. And if it is really going to help, it's just we are open to that. It's just a question of having an understanding and moving forward. We are open to that.
Yeah, thank you.
Shao, you have any questions to the other members?
No further questions on my part.
Okay. Alok, you would like to add something, or you would like to have any questions to the other panel members?
So, you asked a question regarding if there could be any, monitoring solution for blade. I think, one typical solutions that are, that have started being used is like installing sensor on the blade and recording the load. If you know, during the certification process, when you are doing the prototype load measurements, you typically apply the sensors and then you try to measure the loads. So it's similar to that, but these sensors are kind of inbuilt and they are permanent. So that is one area where we see that the blades are being monitored on a real basis. Secondly, we see that a lot of aeroelastic smart materials are being used. What it means that a particular section of the blade which is seeing the I would say excess load. So instead of a controller changing the pitch or changing the orientations, that particular section of the blade will twist in such a way that it will alleviate the load itself. So these two concepts, I would say that they are being used in the blades as a sort of real-time monitoring, and also looking into the lifetime extension or reliability of the blades.
Alok, what you're saying is these are currently available as a product in the market?
I'm not sure, because then you will know, right?
Okay.
but what we know that we are involved in research of these areas, and we are we are very close to publishing paper on that. And these research are with some of the OEMs also.
Okay, right. Akhilesh, are you back?
Sir, Mr. Akhilesh had to leave us because he had an urgent meet.
Okay. So, gentlemen, thank you very much. Let me quickly summarize your views so that the audience gets a gist of it, and then we might take some questions. Sangeeta, it's okay? We are on time, or how is it?
Sir, you can take more of 10 minutes. Absolutely okay.
Yeah. So let me start with Bharat. Bharat stressed the need for maximizing the yield of the wind farm, and he also advocated the decentralized predictive analysis approach. And since now a lot of connectivity has improved, the smart technologies has come. He stressed upon the need for the decentralized predictive analysis and enhance the monitoring. So the level of monitoring, what we do, he was of the opinion that it can be enhanced using the artificial intelligence. And a very important point he stressed upon is the site-based. Every site is different, and we had to have a site-based approach in fine-tuning the wind farms. So that was from Bharat. And next, Amar said. Right amount of data is always required for the analysis, and it is not about having a bigger amount of data, but is always better, and the quality of data is very important. And it is also very important that the number of tools which we have for the analysis doesn't count. It's more on the value based tools, right? The tools which offer more value should be considered, and the real time. And the most important point he said is the experts are not available every time for a technician to take help. So the digitalization process should help the technician with the right amount of data and action, so that he can solve the problems efficiently at the wind farm. Then we move to Mr. Wolf. Wolf talked about the switchover from minerals to synthetic oil, and which has really helped increasing the intervention and the oil changing frequency, and talk the importance about the good performing oil and the grease, and also about the importance of its compatibility. We have to look at the compatibility of oil and grease which we use. And there are also digital systems which are available to monitor the performance of oil and grease. And auto lubrication system, when we asked whether what was his opinion on auto lubrication system, he said yes, auto lubrication systems are good, and it really helps us to maintain the maintenance time as far as we use the fit to use oil and fit to use grease. And then we talked to Akhilesh. Akhilesh, we were asking whether the LM is considering the modular-based design because of the fact that the repairs at the wind farms, either due to lightning or handling damages, are getting more and more, and the time spent is also very high. So he said, yes, that is the approach which has been taken by the blade manufacturers, not only for this, but also considering the that the blade sizes are getting bigger and bigger. The current design will only add more weight to the blade, and it will cause constraints to the transports and logistics, and also it occupies a greater manufacturing space. So jointed blades and the modular design is very much on cards, and the companies are pursuing that. Mr. Cho, we asked some specific questions about the process which can be applied at the wind farms, whether the process, lap laser process, which we said will help us to do the blade repairs at the wind farms. But he said there are very many good practices which are available in the aeronautic sectors, and it's a high time that we look into those techniques and see whether we can take those techniques to the wind turbine blade repairs. Then we talked to Alok. Alok introduce us about the various research topics which are underway, vortex induced vibration reductions, and optimizing the wind farm as a whole, because once the wind farms are installed, we don't have a choice to change the location. So he talked about the need for doing analysis, real-time analysis, and giving inputs to each and every turbine so that the wind farm as a whole is optimized. And also on the he touched upon the research which is happening in the blade front, how they are going to manage the logistics and manufacturing process, as well as the handling the bigger sizes of the blades. And already some researchers are going on in this area. And he also touched upon the other research subjects like magnetic gearbox, the recyclability of the blades, whether the use of considering the use of thermoplastic blades, which will help and enhance the recycling process. And when we asked about the continuous monitoring of the blade, he also talked about the load sensors and other designs which are under research for moving forward. So this is the gist of the main points which were discussed by the speakers. And now I leave the floor open to the audience to have questions. If you have any questions, please put it in the chat box, and also please mention to whom you are asking the question, so that we will take up the questions with the concerned panelists. Thank you very much.
Thank you very much, sir. I believe we have just one question left on the Q&A box. The rest all questions are answered across. Thank you all the key panelists. On behalf of Win Insider, I would like to thank all the key panelists for such an enlightening discussions. It was a great learning experience for all of us. Thank you all the attendees for joining us today, for taking out your precious time. Do join us on, I would like to thank our sponsors once again, our presenting partner, Lap Razor, and our platinum partner, Shell Lubricant Solutions, for joining us. Do join us on the India Offshore Wind Summit 2020, which is going to be focusing on policy, regulatory, and market outlook, scheduled on 27th of August from 2:30 to 5:30. We have NEC Intelligence joining us as an advisory partner. The link is provided on your chat screen. Thank you very much. With this positive note, we would like to end today's webinar. Special thanks to Mr. Rajendran for moderating the session today. Thank you very much.
Thank you. Thank you all.
Thank you,
everyone.
Thank you,
Thank
all.
you very much.
Thank you. Thank you all.
Thanks a lot.
Bye-bye.
Thanks.